What's up everyone, Patrick here, welcome back, and moving on to the next question. Before getting into it, just want to mention that this here, it's written out in the PDF file at the beginning of the section. You can just print that out. You don't have to write out all of these questions. If you're watching this on YouTube, you can go to the description box and there will be a link that takes you to the course website where you can find that PDF. So we're told here that Sarah's parents put money into an account paying 7% per year when she was born to help pay for university. And so Sarah just turned 18 today. She's going to university and the account has $14,000 right now. So two questions. Number one, how much was originally invested when Sarah was born? And then number two, if she decides to keep the money in the account until she's 30 for a 10% down payment on a house, how expensive of a house can she afford then? So before getting into the calculations, I'm going to draw a timeline of what's going on here. I always usually like to draw timelines if possible, just to have a nice visual sense of what's happening. So time zero, that's when Sarah was born. And she's 18 now. And the account has $14,000. So her parents put money here, and then that account made interest, compounded to $14,000 when she's 18. And so in question one, they're asking how much was originally invested. We're going to have to solve for this PV over here. And then in number two, they're saying, let's say that she keeps this amount. She's not going to use it for university. She keeps the money in the account, so it continues to compound until she's 30. And she's going to use that on a down payment on the house. So in part two, what we're going to have to do is calculate the future value. So in part one, we're going backwards in time. In part two, we're going forwards. Also in part one, this here, the 14,000 is going to be the future value, and then we're going to present value it. But in part two, that 14,000 is going to be the present value, and we're going to future value it. Right? So number one, present valuing it. Two ways to do it. We could do it algebraically. So present value is future value over 1 plus r to the power of t. Or we can do it the financial calculator. I'm going to show you both ways. So algebraically, 14,000 over 1 plus 7%, 0.07 in decimals, to the power of 18. We're going to present value this by 18 years from here to here. So we'd end up with 14,000 over 1.07 to the power of 18. You would do this portion first, and then take 14,000 divided by that, and what you would end up with is $4,142 if you round it to the nearest dollar. So that is the answer to number one. That's the amount that was originally invested. You could also check this. You could take this and future value it by 18 years at 7%, and you should get 14,000, something very close just because we rounded it to the nearest dollar. But if you don't round this, right, let's say you take it to like 5 decimal places and then use that amount as the present value and future value, you should get 14,000 exactly. Now, if you wanted to do this with the financial calculator, what would happen is you would input these amounts here and you'd be solving for that PV. So the future value is the 14,000. Because there's not going to be any payments in between, it doesn't really matter if you use positive or negative here, but if you want to intuitively relate it to the question, 14,000 is the amount that you're getting, the amount that you have, so we can have it positive. We're present valuing it by 18 years at 7%, and so the PV that you're going to get is negative 4,142. Right? That's the amount you have to invest. That's why it's a negative. So cash outflow, and then you're going to receive 14,000 in 18 years. So that was the future value. Right? So whichever way you do it, 4,142 is the answer to number 1. Now with number 2, we're going to be going the other way. We have to find out what the future value is going to be if we leave the 14,000 in the account. So number 2, again, 2 ways to do it, algebraically or with the calculator. I'll show you both. So future value is present value 1 plus r to the power of t. So we have 14,000. Remember, that's the present value now, right? We're just looking at this portion. We're going to future value that. 1 plus 0.07 to the power of 12. The difference between these, right? This is going to keep compounding for 12 years, like that. Now for 30, because we're here, right? That's the point of time we're here now. There's 12 years left until she's 30. So this would be 14,000, 1.07 to the power of 12. You would do this portion first, exponents, right, BEDMAS, then multiply it by 14,000, and you'd end up with 31,531 if you round to the nearest dollar. So that's going to be the amount that she's going to have in the account. That's actually not the answer to number 2, because they're asking how expensive the house is going to be, and I'll get to that in a second. But for now, we're just calculating how much is going to be in the account. So this is the way to do it manually with the financial calculator. 14,000 is invested, PV 12 years, 7%, no payments in between, no cash flows in between. Solve for that future value, and you would get that, the same amount, 31,531. So that's how much is going to be in the account when she's 30 if she leaves it there. However, the question is asking what? That's going to be used for a 10% down payment. They're asking how expensive is the house? Well, the value of the house times 10%, 0.1, is going to be the down payment. 10% means 10% of the value of the house. So we have x, what we're solving for, 0.1, and then the down payment is going to be that amount that she's going to put down, 31,531. So divide both sides by 0.1 to isolate for that x, for that value of the house. And when you do that, you'd end up with $315,310. Approximately, if you maybe didn't round this, you had a couple of decimals there, then this would be not to the nearest $10, but to the nearest dollar. But I'm just going to keep it like that. So that's the value of the house, and that's the answer for part 2. So this is like a multiple choice question. Be careful. This answer may be there. But the actual, you got to read the question carefully. The actual answer is a step further. They're asking for the value of the house.